It's May 2023, and I was thinking about getting myself a new PC because my old PC over here draws too much power. It is 5 years old, performance is fine, it works like a charm, but it draws a lot of power and I don't want to consume 100 watts reading my emails. So I was thinking about getting myself a new PC that is more power efficient. So my first idea was to look into mini PCs. These mini PCs use laptop hardware most of the time and are very power efficient. And in fact, I got myself one of those mini PCs with an AMD Ryzen 7 7735HS. So it's very recent, and yeah, from a performance point of view and from an efficiency point of view, this CPU was okay, but the mini PC that I bought for 650 euros was a very bad build quality, and it had issues on the display port, it had issues with the USB-C, and I just sent it back. So yeah, I was back to square one, thinking about building a desktop PC by myself now, using a current processor generation, either Intel or AMD. I didn't really care. To be honest, I have been Team Red for the last 10 years or whatever. I really liked the Ryzen processors. So the first thing that I looked into was the current Ryzen processors. But what CPU to choose? I looked into some benchmarks to find a CPU that I think is suitable for me. And I want to show you what I did. So over here I have my AMD Ryzen 7 2700X that I'm using right now as a baseline, and I will show you the performance of the Ryzen 7735HS that was part of this mini PC that I bought. And the next thing I'm going to show you is the AMD Ryzen 5 7600, not the X version, the regular version, because the X version has a higher TDP. So let's compare these to get started. So over here we have the pass mark, or the CPU mark scores of the processors that we just talked about. My current one is the AMD Ryzen 7 2700X, has a score of 17,500, let's say. Uses 105 watts, and the mini PC that I bought provided more power, drawing less wattage. And that was really nice, but I told you the PC had to go home. Didn't really work out for me. And when I'm thinking about building something myself, having a similar wattage, the AMD Ryzen 5 7600 came up, and that has even more power. How nice is that? So I wanted to build myself the AMD Ryzen 5 7600 computer, but building one of those is kind of expensive because the motherboards are quite expensive and the DDR5 RAM is more expensive than DDR4. It's not a big difference, but I didn't want to build like the fastest computer or something. I wanted to build something that is sane, that makes sense, is fast, is a good bang for buck, is power efficient. So I was not really happy with that, and I was looking into alternatives. And luckily the website over here has a very nice graph that helped me find a suitable CPU, and I will show you right now. So there is this option over here to, where is it? Power performance, the power performance overview. And that's where they take the amount of power that CPUs draw in account to how much computing power they have. And that's really cool. This over here doesn't really help me that much, but the XY scatter graph, that is a really cool tool. Because over here we can see the wattage that these CPUs draw and the pass mark score, the CPU mark score that these CPUs achieve. So we were looking into the 65 watt range over here. And yeah, it's a pretty high range nowadays, obviously, if we don't go for, let's say, the AMD Ryzen 9 7950X 3D with its insane CPU rating and very high TDP. It's pretty much like putting two of the regular CPUs in one CPU, but we're not talking about that. So I was looking into the 65 watt range for alternatives, because these CPUs nowadays, they don't draw 65 watts. That is their, is it max TDP? Anyway, every recent CPU should be very power efficient. But in case you need some power, let's say you are encoding a video or whatnot, these thingies draw up to 65 watts. I know it's a tad bit more complicated, but let's just go with that. The cheapest, or the first CPU that shows over here, is the Intel Core i5 13500. And I was a little bit confused because it has a CPU rating of 33,000 almost. And that's a lot more. Let's go back. That is a lot more than the AMD Ryzen 5 7600. Why is the AMD Ryzen 5 7600 not on that chart? I don't know. It's 28,000. Let's go back. 28,000 is over here. The AMD Ryzen 5 7600 sits right there, and that's a pretty bad score compared to the 13,500 Core i5. So, nice, we have an alternative. And if we just spend a little bit more money, we can get even more power. The 13,600 i5 is a really nice CPU. Let me show you. I'm going to add this to the comparison. And I'm using the regular version. I'm not using the K version because we don't need overclocking. I'm not using the F version because I want the iGPU. This is not a gaming machine. This is a workhorse. I don't need an external GPU. And we're not going to use the T version that uses even less power, because as far as I know, the regular version can emulate the T version by setting the max TDP in your motherboard's BIOS. So it's really nice to just have the option to draw more power because we want it. And if we really want to throttle the CPU down to another TDP, we can do so using the BIOS. But yeah, that's just why I chose the regular version of the i5. And now check this out. It's almost 34K, the score. It's a really, really fast and efficient CPU. What I'm trying to get over here, or what I think I am getting, reading these charts, is a CPU that is pretty much twice as fast as the CPU that I'm using right now by consuming half the power. That will be freaking awesome, right? Well, if that's the case, I don't know. We will see later when I build the PC and measure the wattage that it draws. But yeah, that's how I came up with the Core i5 13,600 as my designated CPU. All right, so now we need a motherboard, right? And for the motherboard, first you have to choose the right chipset that you want to use. And choosing the right chipset can also be confusing, so to say. And what I'm trying to do over here, I'm only getting the cheapest stuff that will provide the power or the features that I need. So I'm not spending money on something that I don't want. Also, if a feature is missing, that feature cannot consume power, right? For instance, a lot of motherboards have Wi-Fi and Bluetooth. I don't want that. I don't need that. So a motherboard without Wi-Fi and Bluetooth, yeah, it lacks a feature, it's cheaper, but it also consumes less power. So I'm looking for the motherboard that has all the features that I want and the right chipset. And now I'm going to look into a chart over here with you and show you how I picked the right chipset for my build. All right, over here we see the different chipsets to choose from. It's the H610, the B660, the H670, and the Z690 as the top tier chipset. Let's start at the bottom because I told you I really want like the most basic thing. It lacks overclocking features. I don't care because I'm not going to overclock. What I really want is dual memory channel support, and the B660 is the first chipset that can provide that, so H610 is out. Following are a few things about I/O. These are all fine. For me, I don't need much I/O. And the next X I'm seeing over here is the RAID support. I'm not planning on building a RAID, so I don't need that. Seems that B660 is the chipset to go. And now that I know which chipset I need, I just went for the cheapest motherboard I could find. It's the ASRock B660M HDV. It is a very, very, let's say, simple motherboard. It has DisplayPort out. I need that for my monitor. It only has 2 memory slots, but I will not use 4, so that's fine. There is no Wi-Fi. There is no Bluetooth. There is... It's pretty much, yeah, it's a very basic motherboard. But I like it. I like it. It was the cheapest option I could find. I hope I will not regret this. On top of the motherboard and the CPU, I will build the PureRock 2 CPU cooler. I'm a sucker for Be Quiet. I don't know. I think there are maybe fans that are less, that are even less loud. But yeah, marketing one. It's called Be Quiet. I like that. And I got myself the PureRock. This should be like super, it's overkill basically, but it was a cheap option. And because this thing will be so efficient in cooling, the fans on this thing should never really spin up. And talking about fans that never should spin up, this is the case fan over here, PureWings 2. I only got one. And if that is not sufficient for airflow, I will have to pimp my build a little bit. There is a fan built in the case, but I don't think it will be any good. Let's talk about the case later. What else did we got? MX4 thermal compound for the CPU and the cooler. For RAM, I got myself 32 gigs of DDR4, 3200 megahertz RAM. I could have opted for 3600 megahertz RAM, but as far as I know, this is really something for gamers and maybe for artificial stress tests where you can see differences in the results. As far as I know, on a daily basis, just working on my machine, the 3200 megahertz will be absolutely sufficient. And yeah, cool. So that's the RAM. Talking about RAM and storage, this is my 1 terabyte SSD over here. It's an M2 a 980 Pro by Samsung. And now I have 1 terabyte of very fast storage. I have 32 gigs of RAM, and that is twice as much as the PC that I bought before, the mini PC. It only had 512 gigs of a no-name brand SSD and 16 gigs of RAM. And I'm just telling you this right now because I think I said that I paid 650 euros for the mini PC. The setup that I'm building right now is 680 euros. So it's pretty much the same price. And I've got way more RAM, way more storage, and way more CPU power. Well, yeah, it's not as small as a mini PC, I know, but I really think that is a good choice. What did we forget? Oh yeah, the what's it called? The power supply. Ugh. I pretty much just tried to find the cheapest power supply that has cable management. It has 80 plus bronze, that is okay. And it has only 450 watts, but that's enough for the build that we are doing right now. The last thing that I have to talk about is the case, and I got the cheapest case that I can find. This is something that I tend to do. I just go to my vendor of choice, select PC cases and sort PC cases by price, and I just buy the cheapest one that I can find. It's really like a challenge for me to not cut myself assembling the PC. And still, still trying to build something that looks good and that works even with the cheapest case. I know I'm a stingy bastard, but yeah, we will see how it goes. So yeah, these are my components of my 2023 build workhorse, power efficient, silent, I hope. Yeah, sane, just something that makes sense to me. It's not too pricey, it's a good bang for buck, and let's see how it goes. I would like to know if you think that my choices are poor. Maybe they are, because I am not a professional PC builder. I'm just doing this every couple of years for fun. But if you have any remarks on the hardware that I chose, and you say, oh, why didn't you get for the i7 13700? Come on, next step. So much more power. I would answer, yes, you are right. But compared to the price gap between the i5 and the i7, I think the i7 doesn't make sense. So I went for the i5. Just let me know in the comments if there is anything that you want to tell me. And now I'm going to build the machine. And I hope my choice of hardware was good. And in the end, I will have a very nice machine over here. Yeah, so the machine is built and I've been using it for a couple of days now. It's still May 2023, the last day of May. And here are my results of the tests that I did. So I've been comparing my old system, my 5-year-old system, to the new system, and I wanted to see if it is more power efficient. So first of all, I checked the power consumption. In standby mode, that means it's shut down, but it's plugged into the wall. The old system consumed 4 watts and the new system only 0.9, which is nice. The second thing I tested was idle power consumption, meaning it has booted up, the operating system is running, and you're not doing anything special. It's just basically you have your emails open, what I said before. So the old system consumed 65 watts of power, and the Core i5 only consumes 30 watts. That's really nice. So that's less than half, really. The next test, it's not really a hardcore test. I basically booted up Minecraft and I just flew over a generated world and looked at the power consumption. So when I did this with the old system, the computer drew 160 watts and the new system draws 75 watts. I didn't check the FPS counter. I'm not a gamer. I don't really care. But yeah, anyway. And last but not least, and that is a very interesting comparison, I ran CPU Mark, the PassMark test program on my computers. And when I did the CPU test, the average power consumed on the old system was 170 watts. You can see that over here. And on the new system, 126 watts. Nice. Yeah, but what does that mean? How much performance gain do we have, and how is the efficiency? The next thing we're going to do is we're going to check the CPU Mark score. And the Ryzen 7 had a score of 17,585 compared to 33,907 of the Core i5. And these numbers, if you check the webpage today, the numbers will be slightly off because PassMark is constantly gathering new data and accumulating the data. And so these scores might not be 100% the scores that you see on Passmark.com today. Anyway, still, as I said before, the performance of the Core i5 is pretty much double compared to the Ryzen 7 from back in the days. Not a big surprise, we knew that before. But let's check out the wattage again. So when I ran the CPU mark test, as I said before, the wattage was 170 on average on the Ryzen 7, and the Core i5 had a 126 watt wattage. What's wattage? So it draws roughly 25% less power on average when you do the CPU mark test suite. But what does that mean in terms of efficiency? So what I did, I basically divided the score using the wattage, and that's how the quotient over here is calculated. And as you can see, we have a score of 103 efficiency score, let's so to say, compared to an efficiency score of 269. And from an efficiency point of view, the new system is 260% better. So it's twice as fast. It consumes less power. Even in the stress test scenario, it consumed 25% less power. Idling or playing Minecraft, it's pretty much half power. And the stress test efficiency is 260. I didn't really check the efficiency in the idle state, but that should be even more. And yeah, that's my build. And I hope this information over here was somewhat entertaining and enlightening for you. And once again, in case you have comments, use the comments function. Let me know what you think about my new system. And if you have anything to say, let me know. So that's it. Bye-bye, and I'll see you next time.